Another important topic in Unit 2 is a components of HVDC transmission system, converter station equipment. Components of HVDC transmission system. Please see the schematic diagram of a typical HVDC converter station. In this diagram, we having 12 pulse converter. The converter act as both rectifier and also inverter. Depend upon firing angle. If the firing angle is less, means less than 90, that will act as a rectifier. More than 90, that will act as a inverter. Normally, the power P is equal to VI cos phi. Whenever the cos phi or cos alpha, the firing angle cos below 90, we get the positive value. Cos above 90, we get the negative value. Positive is a rectifier mode, negative is a inverter mode. This is a pulse converter transformer having the star to star or star to delta. So the transformer, pulse converter transformer configuration must be star to star or with star to delta. Then only a phase shift is possible. Then only a adding of pulse converter is possible. Star to star with star to delta. The star always grounded. Next one is a DC reactors. DC reactors, DC pole bus, DC surge capacitor, DC line arrestor, DC line. This is a station earth damping circuits which consist of inductive and capacitive elements, neutral bus. This is a midpoint. This is earth electrode. Earth is a protective equipment or protection purpose. This is a EL line, earth line. This is DC line, DC terminals, DC reactor, converter unit, arrestor, AC filters. If you observe carefully, we having both filters, AC filters and DC filters. Because in HVDC having both systems, in rectifier there is a AC to DC, in inverter there is a DC to AC. Both AC and DC is available in HVDC. So the filters, AC filters and DC filters are required. The essential components in HVDC transmission system are 6 or 12 or 24 pulse converters, converter transformer with suitable ratio and tap changing filters at both DC and AC side, smoothening reactor in DC side, shunt capacitors and DC transmission lines are there in HVDC station. So normally the pulses are 6 or 12 or 24. Whenever we increasing the pulse number, the requirement of filter circuit is reduces. The converter unit, HVDC transmission requires a converter at each end of the line. The sending end converter act as rectifier which converts AC power to DC power, and the receiving end converter act as an inverter which converts DC power to AC power. This unit usually consists of two three-phase converter which are connected in series to form a 12 pulse converter. The converter consists of 12 thyristor valves, and these valves can be packaged as single valve or double valve or quadrivalve arrangements. Due to the evaluation of power electronic devices, the thyristor valves have been replaced by high power handling devices such as GTOs, gate turn-off thyristors, IGBT insulated bipolar transistors, and light-triggered thyristors. The valves are protected using snubber circuits, gapless surge arresters, and protective firing circuits. So the snubber circuit protects from over voltages. If the system having the over voltages, the snubber circuit protected in over voltages. This is a 12 pulse converter combining operation of two 6 pulses. This is a single valve, this is a quadrivalve, this is a double valve. So the arrangement is star to star with star to delta. This is 12 pulse converter unit. Converter transformer. The transformers used before the rectification of AC in HVDC system are called as converter transformers. The different configuration of the converter transformer include three-phase 2 windings, single phase 3 winding, and single phase 2 winding transformers. The valve side windings of transformers are connected in star and delta with ungrounded neutral, and the AC supply side winding are connected in parallel with grounded neutral. Filters. Due to the repetitive firing of thyristors, harmonics are generated in the HVDC system. These harmonics are transmitted to the AC network and DC LED to the overheating of the equipment and also interference with communication system. In order to reduce the harmonics, filters and filtering techniques are used. Types of filters include AC filters, DC filters. AC filters, these are made with passive components, means inductive and capacitive components, and they provide low impedance and shunt paths for AC harmonic currents. Tuned as well as damped filter arrangements are generally used in HVDC system. Normally tuned filters and damped filters. DC filters. Similar to AC filters, these are also used for filtering the harmonics. Filters used at the DC end usually smaller and less expensive than filter used in AC side. The modern DC filters are of active type in which passive part is reduced to a minimum. Specially designed DC filters are used in HVDC transmission lines in order to reduce the disturbances caused in telecommunication system due to harmonics. Shunt capacitor or reactive compensation. Due to the delay in the firing angle of the converter station, reactive volt-ampere are generated in the process of conversion. Since the DC system does not require or generate any reactive power, this must be suitably compensated by using shunt capacitors connecting at both ends of the system. Smoothing reactor. It is a large series reactor which is used on the DC side to smooth the DC current as well as for protection purpose. It is regulate the DC current to a fixed value by opposing sudden change of the input current from the converter. It can be connected on the line side, neutral side, or at the intermediate locations. This provides two purposes. One is of protection purposes, another one is cannot allow over currents. Transmission medium or lines or cables. Overhead lines act as a most frequent transmission medium for bulk power transmission over land. Two conductors with different polarities are used in HVDC system to transfer the power from sending end to receiving end. The size of the conductors required in DC transmission is small for the same power handling capacity to that of AC transmission. Due to the absence of frequency, there is no skin effect in the conductors. DC and AC switchgears. Normally, switchgear equipment is a protective equipment. So here HVDC consists of both the system AC and DC. So the protection required in both ACs and DCs. That's also a protection devices is nothing but lightning arresters, circuit breakers, relays. These are the protective equipments. The switchgear equipment provides the protection to the entire HVDC system from various electrical faults and also give the metering indication. The switchgear requirements include isolator switches, lightning arrestor, DC breaker, AC breaker, etc. These are the switchgear equipments.